Welcome back to our ICQ Comets and Cousins YouTube channel. This video will discuss news about comets and other small bodies of the solar system that have been watched since our last bi-monthly news video in January. We hope that you have been able to check out our multi-part video interview with Dr. Zdenek Sekanina, which we posted over the past month. We begin with the starring comet of our January news video, Comet 2022 E3. Which put on a splendid show for astrophotographers in late January and early February, if not so much for visual observers. The comet only reached faint naked eye brightness, and to see it via naked eye, you had to have a dark sky and know exactly where to look with binoculars to identify it first. But in long exposure photographs by skilled observers, the comet showed off its bluish-white, sharp, narrow ion tail with structure caused by the solar wind, as well as a shorter, diffuse, yellowish-white dust tail with a greenish glow in the coma due to ionized carbon. The images shown here are taken from posts to our ICQ Comet Observations Facebook forum. Please check out our 2 January videos for more information on this comet. While Comet 2022 E3 was near its brightest in January and February, a dedicated amateur astronomer named Vladimir Bezugly, living in what is sadly the firing zone in Dnipro, Ukraine, had noticed and was closely following what appeared to be possibly a new comet very close to the Sun in publicly available website images taken with an ultraviolet camera named SWAN aboard the solar observing satellite known as SOHO. Bezugly was glad for the distractions from falling Russian bombs via looking for possible comets in SWAN and in SOHO's white light images, as his hard work had paid off in numerous previous comet discoveries. His persistence paid off as the new comet pulled slowly out of the Sun's glare for ground-based observers in late January, and soon enough confirmation was available to announce the comet as 2023 A2 SWAN. Soon after the announcement of the SWAN comet, a new faint comet was announced that may become well visible as a brightish comet in October 2024 and designated C/2023 A3 Tsuchinshan-ATLAS because it was first found on single night images taken on January 9th at the Purple Mountain Observatory in China, whose comets have long been named for the Chinese version of Purple Mountain, and then on images taken with a half-meter Schmidt telescope at Sutherland, South Africa in the course of the Asteroid Terrestrial Impact Last Alert System program, which uses the acronym ATLAS. The comet showed very little cometary activity at discovery, being located more than 7 astronomical units, or AU, from both the Earth and the Sun then. But positional measurements show that Comet 2023 A3 came from the very outer edge of what is called the Oort comet cloud, where the limits of the Sun's gravitational pull keeps comets bound to the solar system. The comet's closest approach to the Sun, or perihelion, will occur on 2024 September 27th at a distance of 0.39 AU from the Sun, which is close to Mercury's distance from the Sun. The closest that comet will come to the Earth is 0.47 AU, or half the Earth's distance from the Sun, or about 182 times farther away than our Moon is, 2 weeks later. While some people are excitedly suggesting that this comet could become spectacularly bright, caution is needed. If the comet is very dusty and it does not fall apart, as some comets do, when nearing the Sun, it could show a nice naked eye tail. But the head of the comet, when at its brightest in early October of next year, will be very close to the Sun and invisible from a dark sky. We'll have to wait and see what transpires. We have seen the announcement of a dozen new comets since January's news video, along with the pre-discoveries of a couple of comets at previous returns and 2 suspected comets from 1951 and 1971 that were confirmed through detective work by Mike Meyer and Gary Kronk in searching through old archival photographs. One of the newly announced comets was discovered as an asteroidal object by the Catalina Sky Survey in southern Arizona in 2010 and given the minor planet designation 2010 VH95 then, but it has been found to show cometary activity in ATLAS survey images this year. And we have another, unfortunately now rare, comet discovery by an amateur astronomer in Germany. longtime comet enthusiast Joost Jan, who found Comet 2023 C1 remotely using a telescope at Haute-Provence Observatory in southern France, after which other observers found pre-discovery images going back to 2013 in professional telescope archival data. Master amateur sleuth Sam Dean of Simi Valley, California, has continued his valuable work in seeking out possible comet images from publicly available data taken with large professional telescopes. He found a tail in images of a presumably asteroidal object found in September 2018 with an orbiting exoplanet survey telescope known by its abbreviation TESS, which allowed that comet to become designated and named. Dean worked with another California amateur named Kay Lee to find 2012 and 2016 images of two other comets that were discovered in 2020 and 2021. And Dean located images taken with the 4-meter reflector at Cerro Tololo in Chile going back to 2013 of Jan's new comet. We now have 456 numbered periodic comets, those that have been observed at multiple apparitions. Shown here is a list of the most recently numbered short-period comets. The name attached to the most numbered comets now is linear, with 61 comets carrying that now inactive survey's name, which is an acronym for a U.S. Air Force telescope located in New Mexico that found hundreds of comets for 2 decades beginning in the late 1990s. Pan-STARRS is in second place with 29, but its ranks are rising rapidly as it has been actively finding new comets, starting with 1 telescope in 2010 and now operating 2 telescopes in Hawaii. The 3rd and 4th place discovery names on the list are also now inactive. The NEAT program run by the Jet Propulsion Laboratory and Rob McNaught's program run from Siding Spring in Australia. Among other comets under observation recently, Comet 96P Machholz reached perihelion on January 31st in its 5.3-year orbit about the Sun. With a perihelion distance of only 0.12 AU from the Sun, this comet is not visible from the ground, but can be observed with sun-observing spacecraft that have occulting disks to blot out the Sun's brightness. And indeed, the SOHO spacecraft captured some nice images of the comet's curving tail as it rounded the Sun. Comet 96P was discovered by veteran amateur comet hunter Don Machholz back in 1986. Machholz, who died suddenly last August from COVID-19, was the most prolific visual discoverer of comets in America over the last century, having found 12 comets that bear his name over a half-century, in which he spent about 9,000 hours hunting for comets with large binoculars and telescopes. 96P was also observed by ground-based observers when further from the Sun, but still visible in small telescopes or large binoculars. The distant periodic comet 29P Schwarzmann-Bachmann continues to have frequent outbursts in brightness, sometimes being seen visually in large telescopes. Comet 2017 K2 has continued to be observed with small telescopes, also showing the greenish coma that is very common in comets that do become visible in large binoculars. Dozens of other comets are observed photographically by amateur astronomers on any given night, and interested people are encouraged to see our publicly available ICQ Comet Observations forum on Facebook. For the cousins part of our YouTube channel, we note 2 interesting recent minor planets making close approaches to the Earth. Minor planet 2023 CX1 was found only hours before it impacted the Earth on February 12th. Visible as a bright fireball from southern England and northern France and other areas of northwestern Europe as it broke up and landed in many pieces in rural Normandy. At least 20 meteorites were found through an organized search of the predicted impact area. 3 meteorite falls have now been accessed following discovery of their parent bodies prior to entering the Earth's atmosphere, all in the past 15 years. Curiously, this latest impact happened on almost exactly the 10th anniversary of the huge Chelyabinsk fireball and meteorite event in Russia that caused the U.S. Congress to double NASA's budget for searching for natural near-Earth objects that can potentially hit the Earth. And on March 25th of this year, minor planet 2023 DZ2 passed by the Earth at a distance much closer to the Earth than the Moon's orbit. Indeed, the biggest long-term risk to the Earth from impacts is likely to be that from so far unknown long-period comets entering the inner solar system, as most of these objects that come close to the Earth that are asteroidal tend to be quite small. Previously, in our November newscast, we discussed the artificial comet that was produced when the DART spacecraft hit the satellite of minor planet 65803, Didymos. The European Southern Observatory has released a montage showing the view of Didymos as viewed from the Very Large Telescope in Chile. Its satellite Dimorphos is not observable in these images from Earth, but the debris cast out from Dimorphos into space surrounding the pair is well shown in these images over a month's time, with a more amorphous cloud of debris evolving into a tail of dust pushed anti-sunward by solar radiation pressure. We are planning a new interview for our April video installment, with our next scheduled news video the following month. Next up in this video is a review of recent research into the Comet 1997 K2 Pan-STARRS by our channel co-host Carl Hergenrother.
In the December 2022 Comets in the News video, we talked about Comet C 2014 UN 271 Bernardinelli-Bernstein, a large comet discovered at a great distance from the Sun. Bernardinelli-Bernstein isn't the only comet in recent years to have been discovered while far from the Sun, and as a result, attracting a lot of attention from the astronomical community. This time we're highlighting recent publications about another comet observed while far out, C 2017 K2 Pan-STARRS. 2017 K2 was at its brightest during the middle months of 2022, when the comet peaked at around 8th magnitude. At that time, it was well observed by both amateur and professional astronomers. Though not an especially bright comet, the number of peer-reviewed papers on K2 is now in the double digits. So why the interest in this comet, and what makes it so special? 2017 K2 was discovered on May 21, 2017, by the Panoramic Survey Telescope and Rapid Response System, better known by its acronym Pan-STARRS, with one of their 1.8 meter telescopes located at the Haleakala Observatory on the Hawaiian island of Maui. At discovery, the comet was around 18th to 19th magnitude and just over 16 AU, or astronomical units, from the Sun. By comparison, 16 AU is further than the distance of Saturn and almost as far as the distance of Uranus from the Sun. Following its discovery, a large number of pre-discovery observations were found going back to May of 2013, when the comet was 23 AU from the Sun, which is almost halfway between the distances of Uranus and Neptune. A paper by Man-Tu Hui of UCLA and another by Malgorzata, Królakowska, and Piotr Dzyński of Poland found that there is a very high probability, on the order of 97 to 98%, that 2017 K2 is an Oort cloud comet and not interstellar in origin. While the Hui results cannot definitively say whether the comet is dynamically new or old, Królakowska and Dzyński found a 97% probability that the comet has passed within 10 AU of the Sun at least once in the past. The Hui paper, and another by Karen Meach of the University of Hawaii, present the many pre-discovery observations found within archival data taken by the Catalina Sky Survey, and with the 3.6 meter Canada, France, Hawaii Telescope, or CFHT. Extrapolating the photometry back in time suggests a start of activity beginning in 2011 to 2012, when the comet was between 25 to 26 AU from the Sun. At those distances, the comet's surface should still have been colder than a frigid 79 Kelvin, which is equivalent to a temperature of negative 194 degrees Celsius and minus 317 degrees Fahrenheit. In addition to the CFHT and Catalina observations, as well as the many other ground-based observations made after its discovery, recent papers also present results derived from observations made with the Hubble Space Telescope, mainly between 2017 and 2021. David Jewett of UCLA and his team found evidence of cometary activity at distances as large as 35 AU from the Sun. Such a distance from the Sun is comparable to the distance of Pluto in the Kuiper Belt. Further analysis of the Hubble data by David Jewett found that the coma observed by Hubble is not consistent with an outburst and consists of dust that has been continuously released and is in steady state production. Based on the lack of a dust tail in those early observations, the observed dust must be large, with a radius larger than 1/10 of a millimeter. The sublimation of ice within a comet's nucleus causes a buildup of gas pressure and an eventual venting of that gas. The escaping gas carries dust with it to create a comet's dust coma. The large dust particles detected in the Hubble images were released when 2017 K2 was very far from the Sun, and as a result, when the comet was still very cold. The big question is whether the accepted processes of dust release are energetic enough to loft such large particles from the nucleus of the comet. Jewett refers to this conundrum as the cohesion bottleneck. So what is the cohesion bottleneck? In order for a particle to escape a comet's nucleus, it must be small enough to be lifted against the gravity of the nucleus by the sublimated particles. But also, that particle must be large enough that it can be lifted against the cohesive forces that hold particles together. At close distances to the Sun, mainly within about 6 to 7 AU, this isn't a problem. But at larger distances, other processes must also be active and support dust release. Jewett and his team proposed two mechanisms that could overcome the cohesion bottleneck. The first is thermal fracturing, caused by changes in surface temperatures due to the day-night cycle as the nucleus rotates. The second is electrostatic charging of particles on the surface of a nucleus by those particles' interactions with the solar wind and solar ultraviolet radiation. Electrostatic charging results in the lofting of particles away from a nucleus's surface. Although 2017 K2 passed through its perihelion on December 19, 2022 at 1.9 AU and is now outbound from the Sun and Earth, it is still visible in backyard telescopes at 8th to 9th magnitude. Though until August of 2023, it will only be visible to Southern Hemisphere observers. After that, it will once again be visible in the Northern Hemisphere, though it will be a much fainter object at around 12th magnitude. Considering that C 2017 K2 Pan-STARRS has been observable since 2013, it is very possible that it will remain observable for many years to come. Hopefully, over these coming years, we will be able to uncover even more of C 2017 K2's secrets.